Yes, so we are back here. We have calculated part A. We have calculated part A, which is what volume of oxygen reacts, then what volume of carbon dioxide is produced. And then we are supposed to calculate what is the total volume of gases left at the end of the reaction. What is the total volume of the gases left at the end of the reaction? So at the end of the reaction, what will be left? That is the question. The question here is for us to identify what are the components of the remaining gases. So at the end of your reaction, you have the product, which is carbon dioxide. Then oxygen, unreacted oxygen. So the first thing, the oxygen that was used is 110. But when you come back to the equation, when you come back up there, the volume of oxygen was 150. The total volume of oxygen was 150. The volume of oxygen used is 110. So from there we can calculate the unreacted oxygen. So unreacted oxygen will be 150 minus 110, which will be 40 centimeters cubic. At the end, there is some oxygen remaining, which is 40. Then again, in this question, we are going to calculate what is the total volume of the gases left at the end. So at the end, what else do we have? We have carbon dioxide. So the volume of carbon dioxide formed is 40 centimeters cubic. So the total will be 40 centimeters cubic unreacted oxygen plus 40 centimeters cubic of the CO2 produced. So the total of the gases at the end will be 80 centimeters cubic. We don't consider water because water, being a liquid, occupies 0 centimeters cubic. Part C. So part C. Question C. In question C, we are asked, calculate the mass of water formed. Calculate the mass of water formed when 9.0 grams of butane is burnt. Calculate the mass of water formed. We need the mass of water. But what are we given? So in part C, I will start it from the equation here. I will start it from here. We are given that butane was 9.0 grams. So we need to have the mass of water, formed. There are two ways of doing this. One, we can get the moles. Then from moles, so we can get the RFM of butane. The RFM of butane is 4 times 12 plus 6. So the RFM will be, that is 12 times 4 plus 6, 54. So this one is 54. Then we get the moles. Moles of butane, which is mass over RFM. Mass over RFM. The mass of butane is 9.0. RFM is 54. So it will be 9 divided by 54, which is 0.0 0.167. So we have 0.1667 centimeters cubic. Not centimeters, sorry, but these are moles. Then, so we will use mole ratios, and in using the mole ratio, we have the ratio of butyl to water. Butyl to water is 2:3. 2 moles forming 3 moles. So what about 0.1667 will give you what number of moles? So this one, you simply say, if 2 represent this, what about 3? So it will be 3 times 0.1667 over 2. So we'll have that one times 3 divided by 2. You get 0.25. So the moles here is 0.25 moles. That is moles of water. So the moles of water is 0.25 moles. But what do we need? We need the mass of water. So we'll come back and say, we'll come back here and have it and say mass of water is equal to moles times RFM. So moles is 0.25 times mass RFM of water is 18. So this one will give us times 18. We have 4.5. So we have 4.5 grams of water. Yes, so we move to question 2. Move to question 2. And because of time, I will be moving very fast now, because now you have at least seen the first one. Now, number 2. What volume of butane must be burnt in oxygen to give 11 grams of CO2 at RTP? What volume? So number 2, butane. Butane is C4H10. Burning in oxygen to give CO2. Burning in oxygen to give CO2 plus water. 4 carbon, 10 hydrogen, 10 hydrogen. Then this one is 5 plus 8, 13. So we'll have 13 over 2. This one will be 2. This one, carbon dioxide, will be 8. And this one will be 10. So we have it like that. A gas, a gas, a gas, a liquid. Then we are told what volume. So 2 volumes, or let us use moles, of butane requires 13 moles. Requires 13 moles, or because 13 times 2 is 26. 18, 16 plus 10, 26. So 13 moles, and this is 8 moles. And then this is 10 moles. Then the next thing is to put the volumes. So what volume of butane must be burnt in oxygen to give 11 grams of CO2? We know that the RFM is the same as 1 mole. So we must convert that into volume. So the mass of carbon dioxide formed is 11 grams. So we must know the volume which is equivalent to 11 grams. we know that 44, if 44 grams of CO2 is the same as occupies 24.0 liters, what about 11 grams of CO2 will occupy what? It will be 11 times 24 over 44. This one will give us, this one goes here 1, goes here 4. 4, this one will give us 6.0 liters. So the volume of CO2 formed is 6 liters, 6.0 liters from our calculation. Now, after knowing that the volume of CO2 formed is 6 liters, we are now going to calculate the volume of butane. And in calculating the volume of butane, we are going to have it this way. We're going to say, if 6 liters, 8 moles represent 6 liters, what about 2 moles? So if 8 moles represent 6.0 liters, what about 2 moles? What about 2 moles? So 2 moles will be 2 times 6.0 over 8, which is 6 divided by 4. So 6 divided by 4 will be 1.5. So this one will be 1.5 liters. 1.5 liters. That one brings us to the end of our class. I will send you assignment in the Google Classroom so that we interact. And where there is a problem, you can just contact me. Otherwise, thank you for listening.